Good afternoon, everybody. I'm working a cubed root version of a problem that was on a 2002 AMC competition. Now, y'all, this SOD stands for sum of the digits, and let's just say, for example, you want to know the sum of the digits of the four-digit number 3,502. Just a very, very straightforward operation. You literally sum up the digits. So this would be equal to 3 plus 5 plus 0 plus 2. What does that add up to? That's equal to 10. Okay. So that's what we mean by the sum of the digits. And by the way, this competition is kind of interesting. I think it's a secondary school competition, and the ones who excel in this competition actually can potentially qualify for the U.S. IMO International Math Olympiad team. Now, this problem here is not particularly difficult, really, other than you just need to know some laws of exponents, and then recall one particular fact about what it means to have trailing zeros. Okay, so let's carry on. Now, again, all very straightforward. Notice that 25 to the 12th is the same as 5 squared raised to the 12th, right? And by the very well-known property of log of exponents, you get the 24 that you see right here. The 24 you see right here is because 2 times 12 is 24, right? And also right here, 8 to the 21st is the same as 2 cubed raised to the 21st power. Okay, and again, you multiply the exponents because you have 21 copies of 3 copies. That gives 63 copies, okay? And also another result that's getting used right here, if you think of this as x to the 1/3, you actually multiply 1/3 times 24 to get 8. Okay, you can just think backwards if you want to. 5 to the 8th cubed is 5 to the 24th, and 2 to the 21st cubed is 2 to the 63rd. Okay, so we get this result, so we know it's equal to this. Now we have a fortunate circumstance here because remember 2 times 5 is equal to 10, right? So we can write this as 5 times 2. Properties of exponents again. 5 times 2 raised to the 8th power. Okay, so we still have 13 of the 2's left right here, right? So you would have times 2 to the 13th, right? Okay, folks. And so this is certainly equal to 10 to the 8th. And that's the whole reason this is, quote, an easy problem. Otherwise, you would have so many digits, you wouldn't be able to do this by hand. Okay, so you have 10 to the 8th times 2 to the 13th. All right. Now, 2 to the 13th certainly ends in a non-zero digit. So it'll be 2 to the 13th, whatever that is, followed by 8 zeros, right? So we know that for a fact. So let me write this. I don't know how to. We'll write it kind of, I guess, symbolically here. It'll be 2 to the 13th. Followed by, I'm not quite sure how to connote this, but we'll just put 2 to the 13th followed by 8 zeros. Okay, now this is probably some extreme abuse of notation here, but what do we need? I need 8 of these. 1, 2, 3, 4, 5, 6, 7. Is that 8? Yeah. 2, 4, 6, 8, right? Now also a little bit of arithmetic will tell you that 2 to the 13th is the same as 8192. And that's something that's achievable. If it's much bigger than that, it's a pain to do, and it's tough enough. But a lot of computer scientists remember that 2 to the 10th is equal to 1024, right? 1024 bytes, I guess. Okay, but anyway, from there you could just multiply this by 8, right? Multiply this by 8, and that gives you the 8192, followed by, we'll take the time to write these down, 8 zeros. Can't count. 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? And so notice all these zeros aren't going to contribute anything to the sum. So the sum of the digits, the SOD here, sum of the digits would just be equal to 8 plus 1 plus 9 plus 2. And of course we can forget the zeros, right? That's the so-called trick of this problem. So what is that? 9, 18, 20, that's equal to 20. So that's the answer to the question. 20. Okay, and again, I wouldn't know how this problem would go if you didn't have a bunch of 2's and 5's. See, 2's and 5's give you the zeros, and then all that's left is some power of 2, hopefully that's manageable. But so anyway, that's the final answer. The sum of the digits of this expression, sum of digits is equal to 20. Thank you for viewing.